In the previous tutorial, we looked into HECRAS model, and we also inserted a bridge covert. In this tutorial, we are going to look at levee, and levees are basically lateral structures. They are physical barriers to help to hold water off, unlike the ineffective flow areas too, where we have water in certain part of the flood plain, but those water are not being accounted for, contributing to the main hydraulics. In this case, we don't even want to see water. We don't want to see water showing up in our channel. So basically, what we are saying is, if we have some, for instance, a levee across this road, the levee should block off the water, so we shouldn't see water going this direction. So to be able to do that, we need to use the levee tool within the HECRAS geometry data editor to do that. So we want to take care of that problem. So we can investigate the cross sections where we will have the problem. We can see in this case we may have water here, and so we want to put a levee that can block up the water, so we can also see the rest of the cross sections. We want to put a levee here to block up this water, and we also want to put a levee here to don't want to see water in the channel. So in that case, the levee can become a very special tool to do that. If in reality they are going to be a wall, so we can do that. So we can start doing that. But to insert a levee, you can go ahead and click on the location we're going to put a levee to get the station number. So you put options, you get levee, and it's on the left side. So the station is 64, and we want the levee to be in the same height as this, so you can go past this elevation, so we can have it a little bit above the elevations. So the levee can be one just above us water source elevation 1141, just to be safe. 40.5, let's put it 141. The levee, like data, we have the levee, so there's blocks of the water. You go to the next cross section, and you see what's going on at this area is gone. So we block of the next, go to the next cross section, want to put the levee here, and go to option, you say levee 5037, and we want it to be above the water elevation here, so this will be 1135. Apply the data, block off this area, go down, want it to be here. Yeah, but the option maybe 60.33, above this variation 1131. Apply data. We can go to the next cross section. We want to put the levee here. Option levee 92.46, and above the elevation here, so that would be 1128 to 0.5. So this is wrong, so we can fix that real quick. Something is off. This is 1127.5. That's the levee. So we can go to the next one. We want the levee here. We say option levee 93.8, and this is to be above this 1111 to 0. To add the levee. So the water is going to stay in the channel. The water is going to not spill to other part of the floodplain. So to do that. So we done put in the levee. You see, we can say save geometry data. And what we want to see is to be able to now see the water here. So we can go to results and a new plan. So that we want to see the 2 year. So we want to add raster layer. We want to add more depth. We want to continue add all the water there. And we want to inspect, so we have to turn off this area. Let's see that here. So when we are done, we don't want to see water in this channel. Just water should be in the channel, but not in the floodplain. So we can see if this works when we run the tool again. So we can go ahead and save the geometry data and go to run steady flow mud mapping. And let's see, this is done. Should close it. Save plan. Go back to RAS-MAPPER. Okay. So this save geometry data. Let it run. It can take quite some time. Reload this. Let's see the. You can see the levee here. Coming. So this has loaded, and now we also find that we still have water in the channel. And this is because we have water spilling into and from other locations into the channel, the floodplain. So we can raise that levee, and this should take care of the problem. So we can go back and see how to fix that problem. So we go to options and levee. So let's increase it, and let's leave it as the same depth of this channel, just above it, so we can have a better result. So we can do 1150 in this case. We hit OK, hit apply. We go to the next one. To keep it at the same top elevations, go to hit so it doesn't really see the channel. So hit levee option. So this is giving us 1144. Okay, it's apply. We go to the next one. We want to use the stop as well. Option levee. That elevation is 1138.6. 38.9. Just to stay safe, we apply. We go to the next one. We want to increase this. So now we see water is spilling out. This is the problem we had here, and that's why we had the problem. So if we go back to RAS-MAPPER, actually, if we turn the 200, yeah, the 100 year is supposed to contain within the channel. So the 100 year is contained in the channel, but we have a problem when we begin to go to 200. In this 200, for example, we see this cross section is contained, but it's not contained for the 500. So we don't want to see water. It depends on what profile we want to be able to accommodate the water source elevation. So we can go back and just making sure, but the proper way is to make sure we go above the water space. So this is showing that we are having spilling, water spilling out for the um, 1000 year or the 1000 year. So we don't want that. We can increase this to the same elevation. So we can do options as we've done. And set it as 1146. Okay, apply data. So this should contain the water now. And in the end, there's also spilling out water here, hydraulics. So we can increase that by raising it to 1124, 125, 1245. By data, and if we go back now, let's say file, save geometry, we can go back and inspect, and we should see that it should be, so we need to run this again and should be able to close RAS-MAPPER, go back to alpha, say heat run, set the flow, and it should contain water in the channel since we have everything started out. So I'm going to open RAS-MAPPER, and while it's opening, I can also see the water is going up. So what is happening is because all that water is staying in the channel, the water has to seep out. So the water is basically rising in the channel since we create that levee. So we can see the water is increasing, the water is increasing, and you can see the water is rising. But the good news is the water is not rising above. But we are having back water going on right now because we've also uh, the rest of them. So we can go and do the investigation and see. So now we have all the water in the channel, all the water in the channel. So now the water is in the channel. We're taking care of this problem. So that's how we set the levee here and to contain that water within the channel. And we can see, yeah, irrespective upstream, we have the problem, we have the water here, but it doesn't really impact us. So um, you can see the problem. This is the 1000 year flow. And we have that water. We can also see where the water is going. We click this and you can see where the water is going. This is the water, because the direction of that water flow into the channel. We have that water coming from here. And so go ahead and tell me what you think could be the problem with this. What could be a challenge with this model? And we can see if we want to make it more representative, we need to extend this cross section from this portion to cover the entire channel. But this is 1D. We just want to see the whole water in the channel. So this is not a 2D model. But for a better representation, the floodplain, we need to extend the cross section to encompass the entire floodplain. Yeah, but we are just interested in this channel for this basic simulation. So what else do you think can be done to improve the water flow here? And this is the 2 year, and you can see. So that's how we basically set up the levee. And we will see that when we set up the levee, we notice that the water surface elevation begin to rise. And because all the water is still going to stay in the channel, but we block off the water from going this direction. So in the next tutorial in the series, we are going to look at how that water can, how we can calculate or look at the the efficiency of the model. We investigate the water surface elevation and investigate um, the headwater over the depth of the bridge opening. So I'll see you in the next video.